Hey guys, Mrs. Flanagan here. Today we are going to talk about set notation and vocabulary, as well as introduce probability. A set is a well-defined collection of distinct objects. Each object in a set is called an element. This is how we notate when we are using a set. We use braces. A set that has no elements is called an empty set, and we use this symbol for that. And if you have the letter N in front of parentheses with the set name, that's asking for the number of elements in our set. Let's do some examples. If we want a set with prime natural numbers less than 10, remember that a prime number is a number that you can divide nicely by 1 and itself. It can't be the actual number 1, but it can be a number that can be divided nicely by 1 and itself. A natural number is just any positive counting number, so no negatives, and it has to be less than 10. So that set then, well, it can't be 1. 2 is a prime. 3 is a prime. 4, not prime because 4 can be divided by other numbers. 5 is a prime. 6 is not prime. 7 is a prime. 8 is not prime. And 9 is not prime. And then this notation here says basically how many elements do we have? Well, we have 1, 2, 3, 4 elements. And so our answer to this would be 4. Now we want even natural numbers that are less than 10. So 1's not even, 2 is even, 4 is even, 6 is even, and 8 is even. And then again, how many elements? There are 1, 2, 3, 4 elements. And so this answer is 4. And then the set of natural numbers that are less than 10, but are multiples of 4. Well, multiples of 4 are 4, 8, 12, but 12 is not less than 10, so it's just 4 and 8. So this is 1, 2 elements, which means N of C is 2. Now let's look at some more definitions. When we talk about subset, this is the notation we use. We would say C is a subset of B, and that means our set C is inside of our set B. Notice that B is the set 2, 4, 6, 8. So B is this entire circle, 2, 4, 6, 8. So it includes everything that C has, right? And then C is just the inside circle. So we would say C is a subset of B. And this is the way we would write that. The intersection is written like this. We would say A intersects B. And if A is the set 2, 3, 5, 7, we're talking about this circle here. Notice this circle contains 2, 3, 5, and 7. And then B is 2, 4, 6, 8. So it's this circle here. The 2, 4, 6, 8 is that circle. And that is our set B. And then set A is the 2, 3, 5, 7. And so the intersection is where they intersect, which is just this 2 right here. So the answer is just the 2 when we talk about intersection. The union then is everything in set A. So set A is 3, 5, 7, 2, and set B is 2, 4, 6, 8. And then the union is talking about everything. So it's actually all of A and all of B. So both circles, all elements, is the answer when we're talking about union. And then this notation here means complement, and that's everything that's not in set A. So set A is 2, 3, 5, 7. So the complement of A is the set of all numbers except for 2, 3, 5, 7. And so the A complement is basically everything that is outside of our circle set A. So it can be any number, it can be 1, it can be 4, it can be 6, it can be 8, it can be 9, and so forth. It just cannot be 2, 3, 5, and 7. Let's do some more examples. Set A is the even integers from 1 to 20. And so this is set A. These are even integers from 1 to 20. And set B is the integers from 1 to 30 that are multiples of 5. So these are multiples of 5 between 1 and 30. And then set C is the prime integers from 2 to 15. These are the prime integers from 2 to 15. And then set D is the odd natural numbers less than 10. And now, if we want to talk about the A union B, remember U stands for union, that's everything in both sets. So we have to look at A and B, and we want to include everything. So A has 2, 4, and then we need the 5, and then 6, 8, 10 is in both sets, and then we need the 12 and the 14 and the 15 and the 16 and the 18 and the 20 and the 25 and the 30. So notice that we have set A, the 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. But we also have set B, 5, 10, 15, 20, 25, and 30. So that is union. It's everything put together. And yes, do put it in order from smallest number to biggest number. It makes it easier to identify that you have actually included everything. So do put them in order. This notation, the rainbow, stands for intersection. So that is in both sets B and C. So we need to look at set B and we need to look at set C and figure out what is in both. So 5 is in both B and C. No 10, no 15, no 20, no 25, 30, so it's just 5. 5 is the only thing that is common between set B and set C. They only have the 5. What I want you to do now is try the example G and the example H. Pause the video and then come back to check your answer. Go ahead and pause the video now. All right, notice that between A and D for the intersection, there's nothing in common, and so we call that the empty set. And then between B and D, the union, it's everything combined. Now let's talk about calculating probability. This is the formula for calculating simple probability, and it's taking the number of elements in the set that you're talking about, and you divide it by the total number of elements. So if this example here is talking about the numbers 1 through 30 being placed in a hat to determine the order in which students will give a class presentation, each student corresponds to one of the numbers. Event A is being one of the first 10 students to give their report. So that means event A are the students who draw numbers 1 through 10 from the hat. Those are the first 10 students who will give the report. And so we can say that the number of elements in set A is 10. And then set B is picking a multiple of 6 as your presentation number. And so multiples of 6 are 6, 12, 18, 24, and 30. And so the number of elements in set B is 6. No, 5. 1, 2, 3, 4, 5. 5. And then the number of elements in our entire thing that we're talking about, so that's the denominator, the total. This is our total, because it's the number of students in the entire class, is 30. It says numbers 1 through 30, so there's 30 students in the class, because all 30 need to give the presentation. So now when we talk about the probability of A, well, there's 10 elements in our set A, and it's out of 30 total. And so we simplify that to 1/3. So a third of the class will be the first 10 students to give the presentation. Remember, this notation means intersection, so we're talking about both A and B. So in both A and B, let's see, there is a 6 is in both A and B, and that is it. And so that means there's only one element in A and B out of 30 total. Now let's talk about the probability of A union B. So union is everything in A and B combined together. So A is just 1 through 10, and then B is 6, but we already counted 6, so we're not going to count that again since it's already included. And then the 12, 18, 24, and 30. So how many elements is that? Well, that's 10, 11, 12, 13, 14. And so it is 14 out of 30, which can be simplified to 7 out of 15. And now let's look at the next example. Remember, this means complement, so that means the probability of not being in set A, so not being the first 10 students picked to present. And so remember, set A is 1 through 10, which has 10 elements, and that means that the complement, so not in set A, is from 11 to 30. So the students who drew the number 11 through 30 in the hat, that's 20 elements. So there's 20 students out of 30 that are not the numbers 1 through 10. And so that can simplify to 2/3. And then the probability of not being in set B, the complement again. Remember, set B is drawing the multiples of 6. That has 5 elements, which means not B is going to have the 25 elements. So it's not going to have the multiples of 6. That means 25 out of 30 will be in not the set B, and that can simplify to 5/6. And then here, the union of A and not being in A, so everything combined together. This is what is in A, and then this is what's not in A. So that's 20 plus 10, that's 30 elements combined. So that's 30 out of 30, which is 1. And for our last example, we are going to use this table to calculate the probability. Remember, this is how we find the probability. We take the number of elements in the set that we're talking about, and we divide that by the total number of elements, so the total of everything, which means looking at this table, the total is 1,000. And so the denominator is going to be 1,000. And what then is the probability of a student having a GPA between 2 and 3? So a GPA between 2 and 3, that is here. right? We're talking about the 25 and the 450, but that means that it's 475 total. So we want the total students that have a GPA between 2 and 3, which means the probability is 475 out of 1,000. And that can simplify to 19/40ths, or you can write it as the decimal 0.475, or you can multiply by 100 to get 47.5%. So either way of writing probability is correct. Write it as a fraction, a decimal, or a percent. And now we want to know, what is the probability that a student has a GPA under 2 and has skipped many classes? All right, GPA under 2 and has skipped many classes. So GPA under 2, we're looking here, and has skipped many classes. So that's the 80. There are 80 students who have skipped many classes and has a GPA under 2. And then again, that's out of 1,000. So that can be simplified to 2 out of 25 if you want to write it as a fraction, or that can simplify to 0.08 if you want to write it as a decimal, or you multiply that decimal by 100 to get the percent of 8%. And something to point out here is the word and is the intersection. So notice that this 80 is the intersection of the GPA under 2 and the skipped many classes. So that's the intersection right there. Our last two examples then. What is the probability that a student has a GPA under 2 or has skipped many classes? So or right here is the union. So it's talking about everything combined between the GPA under 2 or the skipped many classes. So GPA under 2, let's see, there's 80 and 175. So we want to take both the 80 and the 175. And then skipped many classes, there is the 25 and the 5. So the 25 and the 5. And that is still out of our total, which is 1,000. So that is equal to, adding all of those together, is 285 out of 1,000. And 285 out of 1,000 can be simplified to 57 out of 200, or you can write it as the decimal of 0.285, or you can write it as the percentage by multiplying it by 100 and getting 28.5%. For our last example, try this one on your own. Go ahead and pause the video and then come back to check your answer. Go ahead and pause the video now. And your answer is either 7/40ths or 0.175 or 17.5%.